Mr. President, Honorable Assistant, Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. I present a study of structural, microstructural and mechanical properties of a new iron chromium based alloys, carried out in the Material Physiochemistry Laboratory of Shadi Ben Jadid Tarf University. We begin our presentation with an introduction, followed by general experimental procedures, results and discussion, and we will end with a conclusion. The aim of our study is to study the effect of milling time on the new iron chromium phosphorus alloys and follow the structural, microstructural and mechanical properties behavior of iron chromium alloy doped phosphorus. Iron chromium based alloys are used in several fields such as catalysis, ferrofluids, and batteries, thanks to their low oxidation rate, low prices, magnetic properties. The iron chromium equilibrium diagram shows the formation of two salt solutions, a salt solution of chromium in iron phase centroid cubic, a salt solution of iron cubic centroid. We also have a gamma to alpha allotropic transformation by rapid or slow cooling. The iron chromium is always decreased by a miscibility gate for a temperature 820 degrees. There is the possibility of the appearance of a disordered intermediate phase by spinodal decomposition sigma brittles. The diagram of the iron phosphorus binary is characterized by two eutectic transformations, a peritectic one and an allotropic one form alpha iron to gamma iron at high temperature, as well as the possible formation of the 5 defined compounds according to the P concentration and temperature. The phosphorus chromium equilibrium diagram shows the possible existence of 7 intermediate phases, two eutectic transformations, and one peritectic transformation. The representation of the vertical section of the iron chromium phosphorus equilibrium diagram shows the possibility of forming an alpha salt solution as well as different mixture of binaries, in addition to 3-phase file and the single phase one. The elaboration starts from pure elementary iron, chromium, and red phosphorus. Powders handled in a glove box under inert atmosphere to avoid oxidation. The 4 vials were placed at planetary milling time reach PM 400. The milling conditions are vial rotation speed 350, milling time 1 to 4 hours, numbers of balls 5, mass ration 20 of 6, milling cycle 1 hour of milling and 30-minute break. To study the milling effect of the powders, we used the X-ray diffraction in a Breaker D8 type diffractometer in a range of 10 degree to 113 degree with an angular step of 0.02 degree. The simulation of the diagram obtained by the XRD was carried out thanks to the MAUD software, which based on the Rietveld method. The Rietveld method minimizes the residual function by the following relation. With the statistical weight, the experimental intensity, the calculated intensity, structural, microstructural and mechanical parameters, the cell parameter calculated by the relation, microstrain rate given by, or beta, the integral of the Gaussian compounds. Whereas the average grain size with the lambda wavelength of X-ray, theta diffraction angle, K constant, beta width at mid height of the diffraction peak, Poisson coefficient by relation, Young's models, and stored energy. During 1 hour of milling, the XRD show formation of binary iron 94.7, chromium 5.3, and dissolution of P in the matrix, which gives formation of a solid solution. The most intense subspectrum of peaks has a Lorentzian shade. The most intense subspectrum is that of the alpha iron, the P. After 2 hours of milling, the best adjustment is obtained with the same previous phases. But we notice that the intensity of the subspectrum with different peaks. After 3 hours and 4 hours of milling, we see formation of a new iron 30 chromium 70 phase in addition to the alpha iron of P solid solution and the iron 94.7 chromium 5.3 phase. The interspectrum intensity of the solid solution decreases but still remains the highest one. This change in lattice parameter with milling time resulting in crystal lattice compression or elongation. For the solid solution, the cell parameter decreases in the first 3 hours from 0.2883 nanometer to 0.2861 nanometer. A rapid increase between 3 and 4 hours to reach 0.2882 nanometer at 4 hours. Increase in crystalline parameter with milling time. The proportion of solid solution phase decreases in the first 3 hours to 44.7% because of the formation of other phase. The formed iron chromium binary record the highest phase proportion at 2 hours of milling of 35%, then still nearly stable. The evolution of the average grain size as a function of milling time shows the formation of nanometric grains for the solid solution alpha iron at T less 3.5 hours and at T up 1.5 hour for the iron chromium binary phases. The highest microstrains rate is recorded for the iron 30 chromium 70 phase. For the other phases, C2 stability is recorded for this parameter. The Young's model is nearly constant. The iron 94.7 chromium 5.3 phase recorded the highest point ration. For alpha iron of B and iron 30 chromium 70 phase, it's almost stable within 4 hours of milling. A rapid increase of the stored energy is noticed between 3 hour and 4 hour milling to reach 80 for the new phase. In this work we have developed the iron chromium phosphorus alloy in the form of powders using a planetary mill rich PM for handling. Successively XRD result simulation by mouth program, which is based on the red belt method. The best refinement model of the XRD reveals the formation of iron 94.7 chromium 5.3 iron 30 chromium 70 and alpha iron of P after 4 hours of milling. The structural study shows a continuous increase with the milling time of the lattice parameter of the iron chromium binaries. The microstructural properties study has shown that the grain size of alpha iron of P and the iron chromium binaries are nanometric at T less 4 hours at up to 1.5 hours respectively. The mechanical properties study showed that the Young models and the Poisson's ration are stable in the iron 30 chromium 70 and alpha iron of P phases, but the stored energy registered an increase in the alpha in iron 30 chromium 70 phase. Thank you for your attention.